Okay, so in calculus, we're now talking about functions and their graphs. Okay, so functions and their graphs are just talking about the different types of functions and operations you can do. So you can always, with functions, you can add, subtract, divide, and multiply functions together. So those are pretty easy. You guys have done those many times before. Let me put a comma between these two. Okay, now, however, compositions are hugely important because you need to be able to take one function and plug it into another. You've done that with substitution when you solve the system of equations, but from here on out, you're going to be pretty much working with certain notations. So like, for example, just for an example, fog and goff of x. Okay, so what fog actually means is you're taking f as a function and you're plugging in the function g of x in for that. Okay, and goff just means you're taking the function g and you're plugging in f of x for that one. Okay, so you're taking those functions and plugging it in. So like if, for example, I had f of x is equal to x squared minus 3. Ugh. I hate when I forget to type in the closing parentheses. It looks like an emoticon. Alright, and let's say that g of x was equal to negative 2x minus 7. Okay, so if I were to do f of fog, or as I like to call it, it's actually an open dot, but I like to call it fog because it looks like fog, and it just reminds me of it. But what I'm going to actually do is I'm going to take this entire function and put it in for x, square it, and then minus the 3. Okay, now whereas if I did g or goff of x, I would take this entire function, including the x, and plug it into here, times it by negative 2, and then minus 7, and you get two different things. Okay, now what compositions of functions can also do is they can test for inverses. Okay, because if you test for an inverse, fog and goff should equal x if you were testing for inverses, so that's hugely important. It's also useful in substitution, especially in calculus, because one of the harder things that a math student has to do is do integration by substitution. Okay, so as long as you are able to get down compositions of functions, you should be totally cool. Okay? Alright, now if we take a look at just... Okay, if we take a look at what is actually going to be going on with families of functions and their graphs, first off I need to bring it up because this is driving me nuts. Where is it? Desmos, there we go. Okay, so like for example right here, we're taking a look at the actual composition of functions, so let's take a look at... There we go. Okay, let's open it up. Okay, every number, every letter inside of this function is actually doing something else. Okay, so for example, the A is controlling the vertical compression. The H and the B do a combination of moving left to the right, depending on how many units B is. Okay, and K controls the vertical shift. So in other words, if I change the B to like 2, okay, so normally if I change H to 1, it moves to the left 1. But if I change B to 2, in other words, the number inside of the function to 2, and then I move my graph, it moves it a half of what I was supposed to. Instead of moving at 1, it's moving at a half. So that's really interesting to see how B affects the graph. A lot of math teachers don't talk about the B in the family of functions, but I like to because it's hugely important to understand. It's very much like a phase shift in trig. Okay, it definitely affects how your phase shift works and everything. Okay. All right, so just taking a look at that. That is, I believe that is pretty much it of what you're going to be looking at. You do need to be able to identify the family of functions, you know, and just be able to work with it. Now, one of the toughest things to work with is the absolute well, just identifying even and odd functions. So you do need to look for symmetry, and you do need to look for the test, the algebraic test I've talked about before. The algebraic test is basically you take, and I've talked about it, but I haven't gone too much into it, is f of x equals f of x, okay, f of negative x. So in other words, what I'm literally plugging in is negative x into the function, okay, and seeing if I get the same function. So in other words, I would plug it into, let's try it, f of negative x equals parentheses negative x parentheses squared minus 3. Okay, so the function before was the same, so if I plug this in, that's negative x, I'm actually going to get x squared minus 3. That's the same function as before. So this function is actually even because of the algebraic definition. Okay, now if I try plugging it into here, I'm going to get 2x minus 7, which is not the same function, nor is it the opposite. Okay, the opposite would be a positive 2x and a negative 7, which it isn't. Okay, so it's neither even nor odd. So this one doesn't fall under any function category name. Okay, and when also looking at it, you need to be able to identify just by looking at the graph whether it's going to be odd or even. Usually if you can have a 180-degree rotation, that's an odd function because it has a rotational symmetry about the origin, and even functions will be symmetrical with the y-axis. Not any other line, just the straight up y-axis, or x equals 0. Okay, so that should be huge for you guys to learn for even and odd functions. Okay, that's pretty much it for functions and their graphs. So if you have any questions, please feel free to email me, and I will talk to you guys later. Thank you.